Alright, so calculus students, so this one is for sections 3.3, so derivative of trigonometric functions. So here are the new formulas I need to follow through. I mean, can show you the proof for this, but just recognize the pattern here. So derivative of sine of x is cosine of x. Derivative of cosine of x is negative sine of x. So they're kind of like reversing of each other. And then derivative of tangent of x is secant square. And derivative of cosecant, it's negative cosecant times cotangent. And then negative secant, derivative of secant, then that would be secant of x times tangent of x. And derivative of cotangent of x, then that would be considered negative cosecant square of x. As you can see that tangent, cotangent, they're kind of correlated. So tangent is corresponding to secant square, and the cotangent is corresponding to cosecant square. But cotangent derivative is negative. So similarly, cosecant and secant. So cosecant, you have to start it with the original one, but it's negative, but also corresponding with cotangent. And then secant, so you also started with the original secant, but it's positive tangent of x. Okay, so now let's use the following formula to find out the derivative for the trig functions. So to start it off with the first one, differentiate. So that means we want to find the derivative. So started with rewriting. So f of x, so that would be x to the power 1/2 sine of x. So what I did here, just convert that from radical form to the exponential form. And also using the product rule. So f prime of x. So the first function, the second function. So derivative of the first functions. So that would be 1/2 x to the power of negative 1/2 times the original second function. And then plus derivative of the second function, which is the derivative of sine of x, then that'll be cosine of x, and then times the original, the first function, which is what, x to the power 1/2. And then this one is quite similar, so g prime of t. So this one, there's no product, so we just take the derivative separately. So derivative of 4 secant, then that'll be 4 derivative of secant, which is secant and tangent. And then derivative of tangent of t, then that would be considered secant square of t. Okay? And then what about for number 3? Number 3, I mean, you can rationalize it, but it's not required. So using the quotient rule, so y prime can just say that this one is f, this one is g. So always we want to take the quotient. We want to take the square for the denominator. So quantity 1 minus secant of theta square. Okay, so derivative on the top, then that'll be secant theta, tangent theta, times the original g of x, 1 minus secant of theta, and then minus derivative of the denominator, then that'll be considered negative secant theta, tangent theta. And don't forget, times the original f of x, or f of theta. So the rest of this, you can multiply it out, FOIL, distribute, combine the like term. And then for number 4, so that's like a product of 3 different functions here. So if you see the product of different functions, so that would be the structure of y equals f times g times h. So if that's the case, so y prime would be considered f prime times g times h, and then plus f times g times h prime, and then plus f times g prime times h. Okay, so if that's the case. So y prime, then that would be considered 2x times sine x times tangent of x. And then plus x squared times sine of x, derivative of tangent, then that would be considered secant square of x. So basically I'm just using the formula. And then plus f times g prime times h. So times x squared times g prime, so derivative of sine of x, then that would be cosine of x. And then times tangent of x. You can take out the greatest common factor if you want, but it's not required. Okay, so that would be the derivative in general. So now suppose that f pi over 4 is 4. Okay, so that's given. F prime of pi over 4, it's negative 2. So that's the instantaneous rate of change at pi over 4. And then let g of x be f of x sine of x, and h of x equals cosine of x over f of x. So you want to find out g prime of power 4. So started with that g prime of x, just take the derivative in general. So we do have f prime of x, power rule, the product rule, f prime of x times sine of x, and then plus f of x times derivative of sine, which is what? Cosine of x. So plug in the value of x, so pi over 4, so f prime of pi over 4, so sine of pi over 4, and then plus f of pi over 4, plus cosine of pi over 4. Plug in the number. So f prime of pi over 4, then that's negative 2, so sine of pi over 4, so sine of 45 degree, if you do recognize the ratio on a unit circle, it's what? It's root 2 over 2. It's all going back to trig or pre-calc. F of pi over 4, so that one's given, that's 4. Cosine of pi over 4 is also root 2 over 2. Simplified it, so cross cancel, so negative root 2. And then this one here, 2 root 2. Combine them, so then that'd be what? Root 2. And now what about for h prime of pi over 4? Again, just plug in a number. But before we do that, so let's set up the formula first. So let's set up the derivative. So h prime of x. So started off with h of x. So h prime of x. So this one using the quotient rule, so which is what? f of x, quantity square. And then derivative of cosine of x, which is negative sine x times f of x, minus f prime of x times cosine of x. And then plug in a number. So again, this one, let me just rewrite it. That looks kind of ugly. H prime of x. So now plug in that pi over 4. Again, that's the value of x. So negative sine of pi over 4, f of pi over 4, minus f prime of pi over 4, cosine of pi over 4, all over, and f of pi over 4, quantity square. That's a lot of things to put in here. So eventually, so this one is going to be what? Negative root 2 over 2. Because that sine of pi over 4 is root 2 over 2, negative. We just want to carry that over. And f of pi over 4, that's 4. So pretty much using the same quantity. And then f prime of pi over 4. Then that would be negative 2 times cosine of pi over 4, root 2 over 2. And then all over f of pi over 4. So that would be considered 4, quantity square. Evaluate it, so negative root 2 over 2 times 4, then that'll be negative 2 root 2. Because that you want to cross cancel. And this one cross cancel, negative, negative, positive, so plus root 2. And then it's all over 16. So negative root 2 over 16. And that's the final outcome. Okay, so again, it's all about the structure using the product rule, the quotient rule, with the derivative of the trig functions, sine and cosine. And once you set up the general derivative, and then you just want to plug in the value of x, and then evaluate. Okay, so what about this slide here? For what values of x does the graph of f of x equals x plus 2 cosine of x have a horizontal tangent? If that's a horizontal tangent, you guys do recognize that the parabola at the vertex, horizontal tangent, so that means the slope is always 0. So we want to find the derivative in general, once again, so it's 1 plus 2 times derivative of cosine of x, then that'd be negative sine x. So it's written as 1 minus 2 sine x. And then set equal to 0, because that the derivative is 0, so we want to find out the point. So for x here, so it's what? 2 sine x equals 1. So back to trig again. So sine of x equals 1/2. If you try to go around a unit circle, so positive 1/2 for sine, it's either in quadrant 1 or quadrant 2. Okay, so quadrant 1 or quadrant 2. So again, sine, the ratio is always what? Opposite over hypotenuse. Opposite over hypotenuse. So that means the adjacent is root 3. How do you find adjacent? You can use the Pythagorean theorem, or you can use that the ratio, 30, 60, 90 degree triangle. So what's the inverse of sine of 1/2? Well, one of the solution is that it's either 30 degree or pi over 6. In the second quadrant, then that would be considered 5 pi over 6 or 150 degree. So two solution right here. First quadrant, second quadrant. Just want to say x. Okay, so that's the way to do it. Again, it's 1/2, not negative 1/2. The ratio is positive. Okay, so now let's see what else. More formula that I need to know. More limit. So one thing that you guys all struggle, finding limit. So anytime that I see that sine of theta over theta, if theta approaches 0, so the limit for that, it's always 1. Similarly, so sine of n theta over n theta, as theta goes to 0, So where that n, it's the elements of all natural number. So natural number, that means it's like 1, 2, 3, 4, 5, 6, so on and so forth, counting number. So if that's the case, it's always 1. Now what about if that cosine of theta minus 1 over theta as theta approaches 0? So this one, so that means the limit eventually is going to be getting close to 0. Okay, so we're going to use the formula to find out the following limit. So now what about this kind of problem here? So sine of 5x over sine of 7x. So what you can do here, you can just multiply the bottom. Well, let's just separate it out first. So let's say that its limit x goes to 0, so sine of 5 over x. And then the other one, it's what? It's division, right? So limit, so we can always separate it. Limit x goes to 0 for sine of 7x. So now what happens if I multiply this one by 1 over 5? So sine of 5 over x, just multiply by 5 over x, 1 over 5 over x. And then the denominator, what happens if I multiply that by 1 over 7x down the bottom? Now, if that's the case, that means the limit is going to be what? This one is going to be 5, and then this one is going to be 7, because we just want to take out the coefficient. But the thing is that I cannot just simply add the new element. So whatever that you multiply, that means you want to multiply that on the top. Same thing happening here. Whatever that you multiply here, you want to multiply that back to the top. So we do know that the limit for sine of 5x over 5, then that would be considered 5. And you might be wondering, what about the x's? We just cancel out the x's here. Cross cancel. So the limit here, it's just considered what? 1. And the limit here, it's also considered 1. So what we got here, it's just like 5 over 7. Okay, let's see. Is that 5 over 7? Yeah, it is. So once we just put it out, so it's just 5 over 7. And that's the limit for this. Again, sine of 5 over x over 5x, that's just 1. And then sine of 7x over 7x, that's also considered 1. And then 5x over 7x, what is it? 5 over 7. And now what about this one here? So anything that we need to multiply top and the bottom? Well, certainly we can separate it. So cosine of theta minus 1. So multiply that, the denominator, by theta. And also same thing happened down the bottom here. Multiply the denominator by theta. So what happened here? So basically what I did, I just multiplied by 1 over theta, top and the bottom. Again, one thing we notice that limit as theta goes to 0, well, this one turns out to be 0. And then theta goes to 0 for this one, it's 1. So 0 over 1, what is it? 0. And now what about for something like this? So this one can be written as limit, so sine of theta, over theta plus sine of theta over cosine of theta. So you might be wondering, can I separate it? Can I simplify it? Now the denominator, you want to end up with 0. If the denominator is 0, that means the whole thing is undefined. Because tangent of 0, that's 0. Theta goes to 0, so 0. So denominator cannot be 0. So what we can do, we can just simplify the structure here a little bit. So basically multiply by, well, let's just convert that to the same denominator. So on top here, we do have sine of theta. And then the denominator, this one is considered theta plus sine of theta. Well, you might want to put in this. Okay, give me one sec. So theta times cosine of theta. So just convert that to the same denominator. So theta cosine of theta over cosine of theta. Well, just add them first. All over cosine of theta. So now, for those you might be wondering, can I plug in 0 there? Again, that would be considered undefined. Excuse me for a second. Okay, so now let's finish this. So try to do it that way so we cannot plug in the 0 here. So instead of doing all this, again, we're using the same trick like what I showed you for the previous one. So we just multiply the top and the bottom by 1 over theta. So multiply the top and the bottom by 1 over theta, and we'll find out what happened here. So one thing that we noticed, so this one is sine of theta over theta. And then denominator, so theta over theta, because you want to distribute tangent of theta over theta. Hey, you know what? If that's the case, guess what happened with theta? So theta goes to 0. This whole thing is always what? 1. Denominator, this one reduce it. It's always 1. Because theta over theta, reduce. So that's 1. And now what about limit tangent of theta over theta? So if that's the case, so this one is just written as like sine of theta over theta times 1 over cosine of theta. So again, tangent is considered sine over cosine. So what I did here, I just separated out. So this part here, it's always 1 if theta goes to 0. So what's left here, it's cosine of 0. 1 over cosine of 0. What's cosine of 0? That's always 1. So 1 times 1, it's 1. So the limit for this one, which is what? 1/2. So instead of rationalizing it, instead of combining the denominator together, so we can always put this with that, multiply the top and the bottom by 1 over theta. So we can satisfy the formula, which we can apply. Now what about this one here? This one is getting a little bit more complicated. Pi over 4, again, we cannot plug in pi over 4 because that root 2 over 2 minus root 2 over 2, then that'll be 0. So the way to handle this, so let's just put it in 1 minus sine over cosine. Okay. And then the denominator, it's sine of x minus cosine of x. So it looks like this one, we can just simplify it a little bit first. So this one, combine them, so it's considered cosine of x over cosine of x, because 1 is just cosine of x over cosine of x, minus sine x over cosine of x. And now, you see that, things that we can combine together. Okay, so let me just get some space right next to it. Okay, so now this one is just like going back to trig, simplifying the trigonometric expression. So combine this together because that they're all within the same denominator. So cosine of x minus sine of x over cosine of x. And then times, well, once you divide it, that means you multiply its reciprocal. So that one is just multiplied by sine of x minus cosine of x. And one thing that we noticed, these two terms, they're pretty much the same. If you just swap them. So once you swap them, it's like negative 1 times the quantity of sine x minus cosine of x. All over cosine of x. Again, times 1 over sine of x minus cosine of x. This one, cross cancel. So what's left here is just negative 1 over cosine of x. So now, without the restriction, guess what we can do? Plug in the number. So pi over 4. So negative 1 over cosine of pi over 4, root 2 over 2. Take the reciprocals of that, then that'll be negative 2 over root 2. Then that'll be negative root 2. And that's the final limit. So that one is a little bit intense, okay? So you need to simplify the expression first before you plug in the number. Okay, so now let's see what else that we have. The rest of this is just a warm-up using the product rule or the quotient rule. Okay, so make sure that you guys just watch the video over and over again. So especially the part that you're struggling. I'm sure that you guys been struggling with the limit and also going back to pre-calc trig, okay? Make sure that you need to watch, the part of the video right here, especially the way that I put in the analysis for the derivative, product rule, quotient rule, and also the way that I simplify the structure with the limit. Alright, thank you for watching it. So I'll see you guys next time. You guys take care.